Welcome back, everybody. And now we move into our final session of the day. The New Mexico SBIR and STTR Innovation Summit has always been held in collaboration with the Naval Sea Systems Command, also known as NAVSEA, and other defense service components to highlight some of their topics and how they work with applicants and awardees. Now, you will hear from representatives within the Navy and the Air Force who will brief you about their SBIR and STTR programs, how they focus on innovation, and the problems their departments face. Representatives will be chained one after another, so please send in questions during the session, and we will try to address them at the end. But let's get to the panel.
Good afternoon. My name is Jennifer Greenwood. I'm from the Program Executive Office for Unmanned and Small Combatants, PEO USC. Here is our PEO USC portfolio. So we are a very diverse program office at NAVSEA. If you look kind of at that top half of the kind of semicircle chart, you're going to see ship construction. We are responsible for littoral combat ship new construction, the fast frigate, and foreign military sales. And we're also constructing some unmanned platforms as far as the C-frames go. Kind of around that bottom half, you're going to see some of the things that make us unique as far as what we're developing. So obviously unmanned maritime systems is a big deal for us. We're developing all of those different intricacies and autonomies that go into those platforms. We're also doing some naval special warfare work, so that's PMS 340. PMS 408, kind of as I go clockwise around the bottom, PMS 408 is expeditionary missions. And they do some mine warfare and also some diver operations. Right smack dab on the bottom at the 6 o'clock position, you'll see our mine warfare program office. They do all things mine warfare. And on the kind of 7 o'clock position or the 8 o'clock position is LCS mission modules. Those are going to be the different packages for LCS and also some vessels of opportunity. So on this slide, I wanted to define what we're looking to fund. So in PEO USC, we are at the program office level. We are at the POR. So we are looking to transition those technologies quickly. So we're kind of at that point of integration. So we're not doing a lot of early stage R&D. So what we're looking to fund is some R&D to close those technology gaps that's going to help us overcome some significant technical hurdles. We're looking to, look at maybe some novel technical solutions. We'd like to demonstrate feasibility and viability of some cutting edge capabilities. Incremental improvements are always important as things obsolesce, we're looking to kind of replace those with something that's a little bit more state of the art. We're also looking for moderate technical risk and early stage development and potential game-changing technologies. So what we aren't looking to fund, and this can be a very controversial slide, because people seem to get offended that we're not looking to fund some things. And what this slide is really just saying is what we're looking to fund. If we're looking to fund something, if we're not looking to fund something, it doesn't mean that someone else isn't going to fund that. So for example, because we are at that program office level, that integration point, we're not doing a lot of basic research. So we're not looking at that, but that doesn't mean that other places aren't looking to do that in the SBIR realm. So your Office of Naval Research, the Naval Labs, DARPA, obviously those different points of view. National Science Foundation is another one. Those are looking to do a lot more of those researchy, basic research efforts to kind of lay a foundation that we can build on later on in the program office. But right now we're not doing some basic research. We're also not doing analytical or market studies of existing technologies. That's just not what we're interested in. And this comes up every time we have a topic call: engineering solutions without innovation. So a lot of times someone will come with a topic when we're soliciting topics within the program offices, and they'll want to do something, but it's not innovative. And SBIR has to be innovative. So we're looking for that innovation game changer. And we're also really interested in that transition point, being so close to that integration. So projects that don't have a strong chance of transition success are really just not anything we're looking at funding. Like I said, that doesn't mean that someone isn't looking for that. It just means that in PEO USC, that's not where we're trying to build technology. So how to participate? First of all, you got to determine your firm's eligibility. There's some websites listed there. Go to SBA and figure out if you're eligible. Find a topic is step number 2. Review the announcements, review the topics. Obviously, right now is a really great time to check the topics. Check out the topics, see what aligns to your strengths or your potential. Shifting gears right now and kind of changing your identity is really not a great way to step into SBIR. So analyze your strengths, analyze your potential, and find a topic that fits you. Participate in the BAA pre-release, and I will foot stomp that right now. Right now is the BAA pre-release, or the Navy preview of the pre-release. It is a great time to talk to the people who wrote the topics and get their take on it. They can clarify information if you have questions. They can provide added context. They're not going to be able to prescribe a technical approach for you, but they can definitely get you kind of thinking a little bit more along the lines of what they're looking for. Obviously, prepare a proposal. With this, you want to make sure that you are paying attention to the proposal instructions for the BAA that you're looking to propose to. Navy, Air Force, Army, we all participate in SBIR. We all have different requirements for our proposals. MDA is different as well. Across the board, everybody has a SBIR program. Everybody has a different way of doing business. So you want to make sure that you're, preparing your proposal in accordance with those requirements. And step number 5 is submit your proposal. So it's pretty straightforward. It's a lot of work, but if you're tracking and really getting in there with those topic authors during the pre-release, then you should have a fairly good chance. So next slide. Here's our innovation process. And it seems very pragmatic and linear, but really what the takeaway is this slide is in PEO USC, we have a process for everything. As far as technology insertion, technology development, we have a basic process laid out. And what we're just trying, the takeaway here is we want you to know that we have a place for your technology. We don't develop topics for the sake of developing topics. As I mentioned before, we're looking for that transition. We're looking for that tech insertion. So, we have a place for that technology. Before we put pencil to paper on any of the topics, we make sure that we have that transition path kind of thought out and worked through so that we can transition the tech that you're developing. So now on to the topics. So here are our PEO USC 23.1 SBIR topics, and 231035 automatic target recognition in complex underwater environments, and N231036 long range acoustic communication system, N231038 perceptually lossless unmanned underwater vehicle sensor data compression, and N231042 pressure-tolerant electronically steered antennas, it's a mouthful, for satellite communications. The next slide is N231048 signal processing for underwater explosion detection and localization, and N231055 centralized automated fault monitoring. And our last topic is an STTR, N23A T013 unmanned underwater vehicle sensor data transformation tools. On my last slide, I have some basic resources for you if you're looking to get more knowledgeable about SBIR, if you want more information, if you need help. feel free to check out some resources, and as I mentioned before, contact your topic authors because they're going to be able to provide a lot of insight that might be helpful in preparing your proposal. Thank you.
Drew, you are up, and Howard should be starting us off.
All right. Testing.
We can hear you, Howard.
Awesome. Good afternoon, good evening, depending on where you're at. My name is Howard Franklin. I'm the NAPC Headquarters Director at SBIR, Sitter Technology Manager. Do want to say one thing that how to participate, which my colleague prior to me had very well described. That same how to participate applies to me and those to follow. So next slide. Next. All right, command leadership. So we have ComNavC at the top. Underneath ComNavC, we have the executive director. I'm going to take your eyes to the left of the slide, highlighted in orange, highlighted in red in the orange blocks. So you just heard from POUSC. You'll hear from the other POs after myself. Now, if you take your eyes to the bottom of the slide, to the green boxes highlighted in red, those areas are within my territory in regards to technical management in SBIR. So you have your comptroller, that's policy, financial policy, contracts, cybersecurity, digital transformation, industrial operations, NAVC, engineering and logistics, under CO7, undersea warfare, and so on. So what I do here is I have POCs that I contact and in regards to a solicitation to a specific topic or not, where then they go within each organizations and try to find areas where the Navy needs solutions, which generates topics. So this wheel is basically that area which I have oversight over in generating topics. It expands deeper into those organizations, the CO2, CO3, the CO4. If you take your eyes to the lighter shade blue, CO4, okay, the topics that I have here are within that wheelhouse. There are two topics, both from an operational and sustainment perspective, okay? So the two topics you see there, so you see N2310, that is now N231051. Just to let you know that those last three X's would be 051. Okay, so advanced, reliable, wide range hull hydrodynamic appendages. So current appendages where you have your stern flaps, stern wedges, your intercepts, you know, they have a limited solution to certain platforms. The idea here is to make a wide range appendage that can go across multiple platforms and not be an isolated solution. And again, if you go to the SBIR website, there's more information on what that's all about. Again, I will also emphasize reaching out to the topic office there at the bottom to get further information if needed. All right, bottom topic. So that those triple X's are 052. So N231052. So underwater diver applied composite patch repair for crack arresting. Sorry. So right now to fix a crack that is under the hull of a ship, right now you're talking about a significant impact in A-sub-O. The ship has to go into dock. There has to be a team flown to said dock. Basically, you're talking about a 1 to 3 month slip in A-sub-O, and you're not having the ship be operational, which is obviously a significant matter there. With this technology, there's no mill spec, but the testing will be tested to mill standard 1689A. So we're also trying to develop a mill spec for this technology. And if we were to be successful here, we're taking a A-sub-O significant issue for 1 to 3 months, approximately $2 to $3 million, down to keeping the ship operational, again, because you're able to use Navy divers at a cost of about $2,000 to $3,000 to send those Navy divers out. So this is very significant. Has a lot of support by the NAVSEA community and looking for solutions. Thank you.
My slides up. Oh, okay. Hi, can you hear me?
Yes, we can hear you.
So my name is Melanie Parks, and I'm a SBIR coordinator, and I'm representing the Aircraft Carrier Program Office that's located in Washington, D.C. So the topic that the carrier is presenting today is for an improved electromechanical actuator that supports the jet blast deflectors on a Ford class aircraft carrier. So you can see on the slide that I have up, the panels that are sliding down, those are the jet blast deflectors, and the mechanism that's holding it up, that's the electromechanical actuator, and that's what we're working on right there. So that EMA is what rises and lowers the JBDs when an aircraft comes down to land on a carrier, and then it lifts back up as the aircraft moves up and takes off. So in the event of loss of control during an emergency landing, it's critical for those panels to be down flush onto the carrier. There's very limited time to lower the panels. Getting the JBD lowered quickly is imperative to prevent loss of the aircraft and or the pilot. So the original EMA design was unable to meet the emergency lowering requirements. The current design is in operation still on the Ford class flight deck, and it uses a mechanical clutch and brake that controls the descent rate of the JBDs. But the Navy seeks to further mitigate the risk of safe flight deck operations by decreasing the JBD lowering time in the event of loss of control, especially during an emergency landing. So to give you a little background about the constraints, the JBD is very big. It's about 6 feet wide, 10 feet high, and roughly like 5,000 pounds each. And the physical space is very limited due to the proximity to the ship's structure and other components. So it also lives in an environment that's frequently exposed to seawater, jet fuel, grease, and other debris that it's often submersed in. So our intent is to solicit alternative technologies that could integrate into the current EMA design to provide a more effective way of lowering the JBDs during loss of control. So we're looking for alternatives that would possibly affect manual control through local or remote operations. Some technologies to consider would be electrohydraulics, pneumatics, compressed gases, springs, electromagnetic cushioning, or any other novel dynamic control technologies, devices, or materials that could be integrated into the existing EMA design. And this EMA technology has dual purposes in other industries such as construction, mining, aerospace, or heavy manufacturing. So anytime something that's very heavy needs to be moved quickly, we would apply. So in closing, we're requesting improved technology to the current electromechanical actuator that raises and lowers the jet blast deflectors on an aircraft carrier. And it needs to meet the emergency lowering requirements when there's loss of control to keep the aircraft and the pilot safe. So I don't have the topic number readily at hand, but I know it's been posted. Just look for the aircraft carrier topic. It's just the one. And if you have any questions, feel free to reach out. Thank you.
Okay, and now we should have Douglas. Doug, are you there?
Okay. Welcome, everyone. My name is Douglas Marker, as indicated. I am the technology manager within PEOIWS. Let me introduce our organization. PEOIWS is the Program Executive Office Integrated Warfare Systems. And if you look at this particular plot, that section which is up here in the top, can they see the mouse when I move it to Dale? Anyway, this part that's in gold, this is where the combat systems are housed there. For example, over here, we've got the Aegis combat system and other aspects associated with that. Up here, we have foreign sales. Over here, we have IWS. I can hardly read that on my screen here. We have 80 and IWS. I can't read these, 10. So these two have been combined together, but these are the little combat ship and the frigate that's coming on board. I think it's the Columbia class or something like that. And this particular aspect over here, this is the SSDS. These are the combat systems that go aboard, for example, the carriers. Down below here, we have products. I refer to them as elements also. We have organizations such as here, this is IWS-2. IWS-2 is responsible for all of the topside radar systems, EO, IR, the electronic warfare, both active and passive. An exciting part of their portfolio of systems is the high energy laser. So they also have a new program referred to as SBIR. I'll talk about that later. These other two here are the RAM type thing and the NATO Sea Sparrow. Over here we have the IWS-3. IWS-3 is responsible for missiles, launchers, guns, and projectiles, principally. IWS-5 came to us back in 2002 when IWS was stood up. They work with anti-submarine type things, sonar, those kinds of things. And then I think IWS-6 is CEC, Cooperative Engagement Capability. Now, these combat systems and these elements are very significant as far as needing to have additional technology added to them. In increments, we can improve the performance and reduce cost. There are new capabilities that range from artificial intelligence, machine learning, model-based system engineering. We have one topic in that area. And then there are some other areas that we'll be talking about as we go forward. The SBIR program is a very significant program in supporting these new changes. Let's go to the next, let's see, where's page down? Oh, here we go. This is when I move.
Go on the left and click the slide. That's what I would say.
I need some help, folks. How do we get this thing to go to the next one? Here?
If you hover over into it, there should be arrows that everybody else has been clicking on there.
Okay.
I think
So the next one, the first one I'm going to be talking about, it turns out that IWS-2, 3, and 5 are the only ones that are working SBIRs this particular cycle. I will talk about those associated with IWS-2 first, and then we'll go on to IWS-3 and IWS-9. We have 2 STTRs, the rest are SBIRs. There are a total of 14 topics that I'm going to be touching on just briefly. Now, in the case of the first 3 here, if you're looking at your, we have N23T011.
So let's move the slide.
Okay. And we have also N231045. In the case of, and then we have another one I'll talk about. The SBIR system is very significant new program within IWS2. This particular capability will provide 360-degree coverage of surveillance and also targeting. It's going to be using cameras and working various different bands of the spectrum. And the three areas that we're talking about here are this N23T011. The lenses in the IR particularly are larger than what we would like, and they're very expensive. And so we're looking to someone to come up with a novel lens technology that performs a conventional high-quality wide aperture IR lens, but at much lower cost, much less complexity, and overall size. The other one that is associated with this is with so many different cameras, we're going to be getting a lot of different information. That means that the operator is going to have to be able to switch from one frequency to the other. And they want to have, we're looking for something that will fuse these cameras in such a way that they'll make sense and provide information and assist the operators. The situation is such that the program of record is fielding a suite of cameras for shipboard surveillance and targeting. This will include both narrowband field, both narrow field of view and wide field of view cameras operating in multiple wavelength bands, including the IR bands. We are looking for someone to develop a video fusion technology that fuses the imaging information from multiple cameras operating at different wavelengths with bands and into a single optimized video stream. Here, optimized means optimized for both human perception and for machine interpretation. And then there's the last area. With all of this data, we're in a position where we potentially can identify what the targets are by looking at our vast library and also the library that's generated by the SBIR itself. We anticipate that AI/ML will play a major part in accomplishing this. So we're looking for a company to develop a recorder technology that smartly and automatically identifies, captures, processes, organizes, and stores only video data that is useful data. So this is expected to need the application of some sort of AI/ML technology. Also, the volume of data presents a particular challenge. Let's go on to IWS 3. We have two projects here. This first one is N231031. This is one where the folks who have submitted this topic indicated to me that they think that model-based system engineering will help them out. If you look at the title, it says Model-Centric Safety Analysis Tools. The situation is this: the Standard Missile program has a rich history of data collection for multiple variants from a reliability and performance perspective. This preponderance of data makes it cumbersome to proactively maintain the Standard Missile portfolio using legacy methods. So they're looking for someone who will apply model-based system engineering tools to create a model representing the safety process required to develop and deploy advanced Navy munitions systems for use in support of weapon system and explosive safety reviews. This next one, which is N231037, when I heard this, I thought, hey, this is right on the mark. With respect to our gun weapon systems, I think most of you are familiar with what I think Iran has been providing unmanned air vehicles to the Russians. The Navy is very concerned about unmanned aerial systems. And we're looking for, the problem is we can't detect these things like easily. The number of variety of UASs and the need for all aspect coverage makes physical data collection costly in terms of time and money. So we're looking for an automated way to automate visual synthetic data generation using machine learning to develop applicable large data sets that will train algorithms in support of the counter-UAS mission. I think that covers all of those. In IWS 5, we have, this is where the bulk of our topics are. The first one is M23A-2T009. Within the software that we have within the systems that we're working with in this particular area, we have a lot of many lines that are basically referred to as bloating. There are concerns that this bloating software will reduce the, if we can debloat the software correctly, we'll improve cybersecurity, improve ASO, and reduce software maintenance costs. So the current processes do not prioritize efficient code either during development or maintenance phases. And so the problem is excess code is prone to cyber vulnerability and reduced availability. We're looking for a company that can develop a capability to debloat tactical software with an eye toward improving runtime stability and reducing cybersecurity vulnerabilities. This next one is, a lot of people wouldn't think about this, but this is very interesting. The ONR has come up with a material, tributyl tin, I think that's how you pronounce it, oxide. It is a material that is very helpful in keeping the domes from becoming foul. But we have a problem with this. We have no framework and algorithms for predicting the degradation of anti-fouling on sonar domes. So IWS 5 would like someone to develop a framework for capturing this newly available measurement on anti-fouling and create predictive forecasting for anticipated life in service sonar domes. Let's see, I think that covers those. Here's another STTR, N23AT014. We have occasions where we have an issue between the time when the technology is developed or whatever is the new thing that is being entered into the systems. And there's a delta between the time when the work is done and the time when the actual training materials are available. This can be as much as 1 to 2 years. We're hoping to reduce this down to 3 years. You can see that that would be a significant improvement. Just reiterating, when new capabilities are fielded, instructional materials are needed to train the sailors. And so we want to have someone develop a capability that can mine the information generated during the capability development process to accelerate development of instructional material and exam questions. The next topic is N231-029. Here we have a unique situation within the Navy that we have computer bugs that cause problems. I'm going to read the bottom line first on this one. Poorly characterized bugs drive need for multiple engineering releases to each of several baselines. Each ER costs $1 million. IWS is seeking technology that will vastly reduce the number of high consequence bugs that can't be replicated. And as a consequence, we bleed funds trying to fix the things we can't replicate and enable us to determine the likelihood of occurrence of bugs so we can properly assess risk. So I've kind of covered what the situation is. We're looking for a company to develop a framework for continuous recording that can allow real-time collection of key information related to a bug. Also, we want to facilitate recreation of bug conditions to allow fix verification. Let's see, we talked about those two. The next one is the conformal arrays. If you see the picture in the upper left hand there, you'll see that we place conformal arrays on that sail of the submarine. We get fouling that occurs on this, and as a consequence of that fouling, we generate flow noise as the submarine is going through the water. This impairs our ability to get accurate data as far as this sonar. So validating grade sensor performance, but current cleaning technologies are expensive and manpower intensive. IWS is seeking technology to automatically cleanse hull arrays and ensure highly fouled areas are sufficiently clean without over cleaning. That is to say, we don't want to damage this in other areas. So I'll just reiterate, what we're trying to do. We want to develop an automated cleaning device that is effective without damaging the surface being cleaned, and which can detect differentially foul areas and apply the amount of cleaning required. This one is an interesting one. I didn't realize this, but when you're working with sonar, you make some assertions or some guesses, I guess you could almost call them, as to what the performance is going to be. And they have to look at the environment that their signal is going through. So as the USW areas of concern for submarines has expanded, the current local environmental sensing is insufficient to support accurate sensing and targeting. And IWS-5 is collaborating with PMS 40I-85, which would be in PEO subs, and PMA 265, which would be a NAVAIR area, to seek technologies that will which will allow submarines and other USW assets to accurately sense and target at the extended range, with the modern and near future USW warfighting challenge. So the Navy is looking for some company that would expand the Navy's ability to sense environment through use of hybrid gliders and platform launchable systems, such as could be done using an A-size sonobuoy form factor. And we're getting to N231034. Some of you may not be aware of it, but we have arrays that are towed by tow cables. And we're always trying to get better performance from these towed arrays. And we're looking to work with improvements to the actual cables such that we can get more power up and down through the cables so that we can add additional sensors. So the problem in review is lack of an ability to multiplex sensors and power multiple sensors, limit acoustic receiver arrays to the number of array elements that can continuously be serviced by simplistic data and power distribution by the tow cable. So IWS-5 is looking for someone to develop a component that would enable both data multiplexing and power distribution to increase the number of sensor elements and tow cable a tow cable can support. Let's see, going to N231044. I think that going straight to the bottom line up front, IWS 5.0 seeks technology resulting in expeditionary units that at a minimum will provide a trainer, but ideally could enable migration to a model where we have enough units, they're looking to possibly as many as 50, to loan to everyone who actually needs USW-DSS, the most up-to-date version rather than today's paradigm where we find systems on all platforms that might at some point have a USW role up to 200. An unwilling infrastructure that leads to version proliferation. And get this, and lengthy time between updates by as much as 8 years. So you can see this is a serious problem. So the situation is training for the undersea decision support system is stovepipes and located only at select training locations. The problem is that for utilization of the USW DSS requires mastery of numerous disciplines. Can you imagine, say they're having to know all of these different systems, and if he's transferred to another vessel, he's going to have to relearn something. So we want to make sure that we minimize that problem. So we're looking for a company to develop a framework that can support integrated USW C2 training and support expeditionary uses of the resultant training. And I think this is the last one here. This is N231049. We have air assets in the form of aircraft and maritime air patrol reconnaissance aircraft. When they're collecting their data, they have to actually land for the data to be downloaded and analyzed. So the problem is this: lacking a method to triage and export video that could be important. Airborne video systems can not effectively support real-time operations. This limits the utility of airborne video to post-mission analysis. And IWS 5 is requesting that the company develop an automated tool that can triage incoming video to highlight video vignettes that are highly probable to be of tactical significance. Also, we probably have to propose an architecture that can support transmission of a compact file to support tactical decisions based on the video vignettes deemed significant. Now, I've talked a lot about this. I think that it's important for you to understand that all the topics that we have are developed within the individual NPMs. And those NPMs, like the radar people, they come into us with their priorities. And we then go across the NPMs that have submitted topics, and we neck them down to the ones that we submit. So there's a high probability that when these topics are done, that they'll transition. Within IWS, we have something like, we've been as high as 54%. Right now, we're down around 48% of the topics of our SBIR topics are receiving phase 3 funding since 2002, when IWS was stood up to the present time. If we go back and look at all of those. So we're looking forward to your submissions. I would reiterate what has been said before. You have the opportunity of speaking with the actual authors to get much more detail. I've spent about 1 minute, I think, per each one of these at the very top level. So take advantage of talking with the actual individuals who are working with it. Don't try to be in marketing mode, because I recuse myself, for example. Just get data that you need to generate your particular topic. Some might be saying, well, hey, you only put up 14 topics this year. It's because we're using more reachbacks in commercialization range programs. But still, we've got some very significant ones here. So we look forward to your proposals, and we wish you well. Have a good day.
Hey everyone, I'm Emily Novak. I'm the technology manager for Team Ships. I say Team Ships because we're a combination of C21 and PEO Ships, Program Executive Office Ships. Next two slides show how Team Ships is broken down, and I wanted to show you it so you could see our program offices and how our topics are distributed through it. This first one is the PEO Ships overview. This organization manages the design, new construction, and acquisition for destroyers, amphibious ships, boats, and crafts. And we've got a bulk of our topics within PEO Ships. You could see on the wagon wheel of the program offices. We've got topics from PMS 460, which is DDGX. We've got topics from PMS 300, boats and crafts, from PMS 377, which is LPD, PMS 400D. We have two topics from there with DDG 51. And we also have a topic from PMS 385, which is strategic and theater sea lift. These topics are looking at things like autonomous controls, electric propulsion, high temperature superconducting cables, distance measurement, cold and resistant materials, and cargo stabilization. The next slide shows our NAVC21 organization. They're our lifecycle management organization. They do all the maintenance, modernization, training for the fleet. They also deal with inactivation of ships and some international things. We have one topic from C21, and this one is from PMS 407, which is the Fleet Modernization Program Office, and this one has to do with protective covers. In each of these program offices, in each of these slices of the pie, we've got SBIR lead that we meet with monthly. So we get our technology ideas from them, and we also bring them things that we get from you in our one-on-ones and try to let them know what the state of the art of the technology is. So we do review their portfolio, and they are transition agents. So everything that we do really has to be a pull from them. So if you do, I know that I've had one-on-ones that I'm going to be scheduling with some of you. You guys have reached out. So we'll look at which program office the technology applies to. So think about that. Look at these two slides and, think about how it fits in. The topics I'm going to go over, there's 7 of them. The first one is N231-028, Autonomous Hall Mechanical and Electrical Controls. This one is for the PMS 460 DDGX Guided Missile Destroyer Office. And this one's targeting operators of HM&E control systems. These operators are responsible for monitoring and operating engineering plants, and they also have to detect, diagnose, and troubleshoot and do recovery of machinery casualties. And so this topic is looking at using some technology to help them out to reduce their cognitive burden and ideally to help them have a more timely response and recovery from any sort of engineering plant casualties, and then also to help with communications and connections between the plants on board and Navy ships, and then overall looking to help with the overall survivability of the ship. The next topic is N231-033. This is the transparent SPY-1 array covers. I have a picture of the slide to show you what an array cover was. This is just an example. Behind this array, there's all these different little antennas, and they are covered by this highly specialized cover. It has a coating on it that is very hard to apply. It requires special equipment, certifications of sailors, and then if it gets damaged or it needs to be resurfaced, the resurfacing is highly involved. There's a lot of environmental concerns, and so the Navy has an interest in trying to extend the cover lifespan, and so they're looking for a solution that develops a transparent cover, allows it to function, and ideally it's going to reduce how often it needs to be resurfaced, which will lead to reduced repair costs and environmental impacts. Next one is 231-039, Boats and Combatant Craft Electric Drive Propulsion System out of PMS 300. The boats and crafts, a lot of them have large diesel engines that consume a lot of gas. They're not very efficient when the boats operate at low speeds. And so this topic is looking to increase energy efficiency by getting an electric drive propulsion system developed. And if they have a solution, they want to be able to increase fuel economy, capability, payload capacity, and decrease the total ownership cost. Next topic is 231-040. This is the high temperature superconducting wire bundles. This one's for PMS 377 with LPD 17. And LPD 28s and follows are installing what's called a high temperature superconducting degaussing system. These degaussing systems will adjust the magnetic signatures of ships and lower them so that they can safely go through oceans and waterways. And the cables for these systems are all fixed lengths. They're based on drawings that, and they have to be very specific. The cables can't be cut too short, too long. If that happens, it's, long lead times to manufacture. It adds cost, it adds time. So right now, these cables are all pre-manufactured to a length. And this topic is looking to give them some flexibility so that they can have cables that are pulled throughout the ship and cut to length at the time of installation instead of doing it ahead of time, so that they don't have to prefabricate and they're going to save time and cost. Next one is N231-043, Extreme Cold Weather Resistant Gasket Material. This is for PMS 400D. They are the DDG-51 new construction. DDGs are in the polar regions. They're going to continue to sail on missions, and it's really harsh environments for them. the seals and gaskets on board ships are exposed to really cold weather, can get down to -50 degrees Fahrenheit. And they're looking for seals that can withstand these really harsh environments and sustain heavy loads and everything that's going to be encountered on ships. And so they're looking for a material that's going to help with some seal degradation issues and improve life cycle cost savings. I skipped one, which is the 231041 topic. That's the improved distance measurement during underway replenishments. And that one is also for PMS 400D, DDG 51. This one is DDG 51s are at sea for a long time, so they're going to have to get replenishments. They got to get supplies. And so what they do is they connect the ships, and the ships have to maintain a very precise distance so that they can transfer cargo and boats and crafts and anything like that. And so right now they have a flag line that's between the ships to monitor and manage the distance. And it's labor intensive because you have to have crew to be able to monitor this flag. So they're looking for a portable device that doesn't require as much manpower and that can accurately measure the distance and then still take into account all of the environmental things that you're going to encounter, such as fog, salt spray, movement, anything, that comes with that. So overall, hoping to reduce labor costs associated with it and improve safety of crew. And my last topic is the autonomous crane system for payload motion controls. Is 231050. This is with PMS 385 Strategic and Theater Sea Lift, and it's targeting the Expeditionary Fast Transport Platform, EPF. And this one, they have to move cargo and equipment at sea, and they use a crane. And the crane has very skilled operators that are trying to minimize the swinging or any sort of movement of the load, but you can't control that 100%. So what they do is they'll utilize tagline handlers that are trying to stabilize it in addition to the crane operator. And as you can imagine, the operators are on deck. They're exposed to whatever weather is on it, and the load is moving, and so it can be hazardous. And so what they're looking for is a technology that can reduce the need for these tagline handlers when the cargo is being moved. And it will really help with sailor safety is the goal. So that is the conclusion of my topics. And if you see anything that's of interest, check out the pre-release and make note of any requirements, questions you have, and reach out to the topic authors.
Okay. See, I'm not on mute, so that's good. Good afternoon. My name is. Oh, okay, thanks. Forgot that one more thing. Here. See it right there. All right. Great. I see I'm not on mute, and now I'm on the right slide. So, my name is Roberto Sanchez, and I'm technology manager for Team Submarines. Like most of the other technology managers, the highest priority is given to topics with transition support. Therefore, I would like to review the organization chart for Team Sub. Team Sub consists of 3 different PEOs: undersea warfare systems, attack submarines, and strategic submarines. On the left is undersea warfare systems, and that is led by Mr. McClatchy. Undersea warfare systems is responsible for various systems supporting the undersea system. And some of these programs are PMS 401, which is submarine acoustic systems, PMS 404, which is undersea weapons, and they have one topic under my BA this year. PMS 425, combat weapons and control. PMS 415, which is undersea defensive warfare systems. PMS 435, which is electromagnetic systems. They also have an STTR in this BAA. PMS 485, maritime surveillance systems. And we've got the training and readiness group and the undersea domain program integration office. On to the right of UWS is PEO SSN, and that's led by Admiral Rucker. He supports the in-service and new construction. Under new construction, we have PMS 450, delivering the remaining Virginia-class submarines, and we also have PEO SSNX, which is developing the new attack boat. Additionally, we have Sub 073, which is undersea technology, and they have 2 topics for this PA. On the far right is the third PEO, that is PEO SSBN, or Strategic Submarines. That's led by Admiral Papano. He is responsible for the maintenance and operation of Ohio-class submarines, and he uses PMS 396 to oversee that portion. Additionally, PMS 397 is charged with delivering the Columbia in time to relieve the sunsetting Ohio class. So given that quick introduction, I'll move on to my first topic. And this is a PEO UWS topic, as I mentioned earlier. It's a PEO UWS, and that's PMS 404, Undersea Weapons. And the title for this one, title for this is Revolutionize Undersea Training Target Motors. The objective is modernize, innovate, and improve the efficiency of the Mark 39 EMAT motor that leverages advancements in printed circuit board setters, as well as reduction in space, noise, and weight of the motor, enabling additional capabilities in the EMAT. So the EMAT is a low-cost training target that is employed to simulate real-world adversaries. Any improvement that we can make in the runtime will extend the training evolution to better simulate real-world adversaries and have our crews better prepared to meet their mission. The next slide here is now the PEO SSN topic, and that's supported by Sub 073. The title here is Alternative Materials and Fabrication Processes for U.S. Navy Propulsor Shafting. So the objective here is develop a low-cost, non-traditional materials and repeatable, reliable, efficient, and robust manufacturing processes suitable for large, thick, waterborne propulsor shafting subject to long-duration, complex stress states. So what we have is traditional, because what we know is traditional metallic submarine propulsor shafts are at the limit of their capacity or the capability due to the size and weight of these metal shafts. While we already have non-metallic propulsor shaftings already in service on other platforms in the Navy, the current scale and size is insufficient to meet the targeted performance metrics of both the current and the future submarines. My next topic is also a PEO SSN topic, and it's also supported by 773. The title of this topic is Structural Design Process for High Cycle Fatigue Performance Composite Material Structures. And the objective here is to develop, execute, and validate methodologies to efficiently establish high confidence design allowables for high cycle fatigue performance composite materials and structures. While composites are already in use, we have an interest in applications that require a much larger number of load cycles over the lifetime. By identifying and developing efficient test methods to reduce the duration of the test process, smarter choices can be made early in the design process when building and designing a new submarine. Okay. My final topic is an STTR. This is a PEO UWS topic and supported by PMS 435, which is electromagnetic systems. The title of this topic is Atmospheric Aerosol Model and Data Collection over the Marine Boundary Layer for Imaging, RF, and Laser Beam Propagation. The objective is to develop a periscope imaging, electronic warfare, and high-energy laser beam propagation model over the marine aerosol boundary layer for integration of propagation modeling software into a system that will investigate absorption and scattering properties of marine aerosols. So here, what the Navy is seeking is we want technologies that are oriented towards deeper experimental and theoretical knowledge, understanding of marine turbulence and beam propagation in the marine boundary layer. And that concludes the last of my topics. We'll turn it over to you over there in New Mexico to carry on the rest of the program.
So thank you, Roberto, and thank you to all of our Navy topic managers and presenters. Now we are going to switch over to Air Force Research Laboratory with Mike Williams. Mike, you should be good to go.
Great. Thank you, Dell. I appreciate that. Special shout out, Dell, to you and the Airhead group for putting this on. Quick, funny little story. I didn't realize this was going to be virtual. A couple of months ago when we were first engaging on this, I kept asking everybody, who's going to set up the booth? Where's the booth going to be? I was all excited about being part of the booth and being there with you, but hopefully next year we'll be back on track and we'll be all there in person. So again, appreciate you, Dell, and all you guys do to make this event happen for us. So again, my name is Mike Williams. I am with the AFWERX Air Force Ventures side of the house, and I'll be talking to you a little bit about our topics, the primary focus on those topics. And I currently work as a program manager in the sustainment side of our STRATFI TACFI program. We'll talk a little bit more about what those acronyms mean and what part of they are for the program. Just real briefly, so most of you are already familiar. I'm sure you've been here all day looking at a lot of these slides, but the SBIR program was established by Congress in 1982 as a three-phase process, soliciting proposals and awards and finding small businesses for federal research and development production services or any combination of those to meet agency needs and missions. And then the small business technology transfer was established in 1992 with a similar statutory purpose. The major difference between those two programs is, as you know, the STTR is reaching out to the universities, federal funded R&D centers, and qualified nonprofit research institutions. So interesting, so the 1982 was the first SBIR that was released. Here in New Mexico, I've been working on SBIR programs since 1984, and it's interesting to come full circle and see some of the topics that we worked on way back in the early 1980s, some of the Star War initiatives on some of our programs that we were working on back then, and seeing them actually delivered into weapon systems now. So it's a real program, works really well. It's exciting to be part of something like this, so I'm excited about being here. It's a three-phase program, as you're already well aware of. With the end goal being commercialization and transition. How do we take these types of technologies and how do we take them from the cradle and get them into the hands of the warfighter and the people that need them, the customers on that side? So I'm just going to go ahead and dive straight into our part of the program. So part of Air Force Ventures, there's several different components within the whole AFWERX area. We have what we call our Spark. We also have our Prime and Air Force Ventures. We're going to be speaking mostly on the Air Force Ventures side. So on the open topic, and we'll dive into a little bit more about what that means as part of the Department of Air Force outreach. So it's technology agnostic solicitation, which encourages commercial industry to submit dual-use technology solutions without necessarily having a known end user. So it's you guys telling us, here's what we think you guys need, and this is the best way to be able to get that technology into the hands of the people that need that. Specific topic, 40% of our budget goes towards that. Specific topics are more a very particular defined set, and the topic requirements are not dual use capability, and are specific to the DoD, but overall these topics have clearly defined requirements and a known Department of Air Force customer built into the topic solicitation. Most of you are probably listening to this are more familiar with the specific topic side, which was more of like our SBIR, STTR legacy program. And then another venture that we have within our group is called our StratFi TACFi. We'll dive into more detail about it as we go forward. StratFi stands for Strategic Funding and Increase Program, and TACFi is the Tactical Funding and Increase Program. These basically are the awards that we use to try to help bootstrap over the valley of death and get people from a phase 2 into something that can actually get its hands into the get that technology in the hands of the end user, the PEOs, and the people that need that technology. So how does our program work? So it's a 3-phase program, just following right along with the SBIR program. Phase 1 is a feasibility study. We've broken up, we've talked about open and specific topics. So our open topic, we award up to $75K per award. It's a 3-month period of performance, and we've already had probably about 700 awards per year is what we're on right now. And again, it's that open door for innovation. It's you coming in and telling us, here's what we think you need. We've got this technology, and we know where we can insert that. Specific topic, again, we have is more of the traditional SBIR, STTR program in the Air Force. It has up to $150K per award, a 9-month period of performance, and we're on track for about 300 awards per year on our specific topic. So in that, of course, we have that built-in Air Force customer, and that's where we do all of our pitch days. If you're not familiar with those, you can go to our afworks.com site and find out more information about those as well. Phase 2. So that's where we're doing our prototype. So we cater to the open topics, specific topics, direct to phase 2s. We call those D2P2s. And in the open topic in our phase 2, you can have up to a $1.25 million per award, up to a 21-month period of performance, and about 300 awards per year on that right now. Customer memorandum is required. Matched funding is encouraged. Our direct to phase 2 opportunity of the customer is already known, and a customer memorandum is already assigned with that. Specific topic, up to 1.25 million per initial award, and 1.7 for our STTRs, up to a 27-month period of performance on the specific topic side, and we're currently hitting about 200 awards per year in that phase 2 for that space. We have built-in Air Force customers, as we've discussed already. It includes those pitch day opportunities as well. Something that is new in our 3rd phase is a StratFi TACFi. A lot of you may or may not be familiar with it. We're working into our 3rd installment of the StratFi TACFi. We do that per program year. We started in FY20, and we have FY21s, FY22s, and getting ready to talk about FY23s. And we'll talk about that more as we go on. So again, StratFi stands for the Strategic Funding Increase, and TACFi Funding Increase for TACFi. So we have those annual notices of opportunity. The TACFi can be up to 375K and 1.8 million of SBIR funds. The StratFi is from 3 million to 15 million, and the currently about 100 TACFis and 15 StratFis is the track that we're on awards per year for that. These are, again, defense only and dual use matching options, and private investor opportunities are encouraged. Phase 3. Phase 3 is the goal of the program, right? That's why we're trying to bring these programs to the point where they can graduate and move into a phase 3 commercialization transition opportunity. So it's continuation, derivation, or extension of the SBIR phase 1, 2, or a StratFi TACFi work. contracting that with partnering U.S. customers and utilizing non-SBIR funds. So focus on that. There's no SBIR funds that are in the phase 3 space. So again, phase 3, that is the goal of the program. We hope that everyone moves from a phase 1 to phase 3. If you're in our program, as the policy directive describes by the Small Business Administration, you've competed if you've already won a phase 1. You don't have to graduate through the phase 2 StratFi, TACFi to go to phase 3. If you have a customer and you have a mature product with the TRLs and MRLs to support it and a customer willing, you can move to phase 3 at any time. So what's our schedule look like? So this is our current predictable schedule that we have. This is our annual cycle. So this will be happening year after year. We tried to put this down so that there's predictability and repeatability in it, and it's reliable. So you can see our fall D2, P2 schedule, our winter phase 1, our spring D2, P2, and again, this is for the open topic, the summer phase 1, and the fall direct to phase 2. And you can see as we carry out, we've got the end here of this last quarter, October through December, starting with January, moving across all the way from 2023 into 2024. So our specific
Quick for you, Mike, before we kind of get into topics, we did have a question come in. Sorry, it was, I think, a really good question and is appropriate to address now because you were talking about StratFi and TACFi. Are those considered second phase 2s?
That's a good question. So originally when we started our StratFi TACFi program, we actually rolled them out as phase 2 extensions, but now we are currently doing that in our current rollout of those as a second phase 2. So very good question.
Great to carry on, sir.
Yep, great. So our specific topic follows the OSD cycle, and you'll see, we've got the FY.1A, FY.2B, FY.3C. So the BAA pre-release, obviously we're into that for the FY1 coming up here now this month in December, and we have the BAA opening is going to be in January for that. The BAA close in February, and we're shooting for 90-day award timelines on those, and that's in May. And then the 180-day statute that's in place is for August. So we're trying to hit the 90 days if we can for our awards. So we're trying to pick that up and streamline that capability and process. And the same with the FY2s. So we've got the release in April, the open in May, the close in June, the award timeline from September to December. The FY.3 following that specific topic OSD cycle is in the August for the BAA pre-release, September for the open, October for the close, January for the award, between January and April for the award timeline. Again, we're trying to put this in a place to where it can be predictable, repeatable, and standardized. So that's the goal with establishing those schedules. Where are we now? So currently, our 22.2B specific topic, we've completed the pre-release. The open period has been completed, the closed period completed. We have the expected awards supposed to be sometime released this month, so keep your ears open and your emails open and that. We have the 22.4/D. Again, that pre-release has been completed for a specific topic. The open has been completed and the close time's been completed, and we're looking for an August 2023 expected award time frame for those 22.4s that have already been released. On our fall 22, our direct to phase 2s, we spoke a little bit about that opportunity in phase 2 space. We have the open topic and orbital prime as well. Pre-release on those have been completed. The open completed and the close completed, and we're looking for award dates of February 2023. So you should be hearing something on those in February. Continuing on a little bit more with the other future solicitations that we have, not the current ones, but the ones that are in the future. So we're projecting the 23.1s for that pre-release date of 11 January, the open starting 8 February, close in 8 March, and expected awards again between that June, September. The 23.3 pre-release 23 August, open 20 September, close 18 October, and then expected awards in that January, March of 2024 timeframe. So the winter 23 phase 1 coming up, the pre-release is not available, but looks like we're doing the open starting in 11 January and 28 February the close, and again the expected awards in May 2023. And again, those can all be found at the DCIP site when those are being released. So that'd be the Defense Cyber Sitter Innovation Portal is where we put all our releases when they come out. So those BAAs will be available at those time frames that we're showing here in our schedule. So Strat5 program, what's our current status now? So we talked about we've done the FY20, the FY21. Currently, we're looking at our FY22 Strat5s are currently in our board review. We get a lot of email traffic about those. What's the status of them? Where are they? If you have one that's in the queue for that, you have a unique ID assigned to it. If you go to our AFWorks af.mil site, you'll see a way to be able to engage to find out what the status of that current solicitation award is. So it's going to be in the, the 6 steps that you have: the initial review, the Air Force Functional Strategic Review, Air Force Ventures Board Review, which is where we are right now, the SBA review, and the stakeholder execution side, and then finally the award. So again, if you move to our site, if you happen to have something that you've put in a proposal for, if you go up to that site, you can put in the unique ID that was assigned to you when you submitted your proposal, and you can check on what that status is on that Strat5 TAC5. So how can you participate? How do you get involved with our program? So again, we have our 3 programs: the open topic, specific topic, and the Strat5 TAC5. So our open topic, again, is this broad opportunity for the industry to tell us, what we need and how we can, best get that put into our system so that we can get it into the hands of the warfighter. So the industry submits solicitations under the open door for innovation. The Department of Air Force users can sign up with an open topic evaluation, finance, and contracting augmentees. So we're always looking for opportunities, how we can get other folks within our organization to help out during those evaluations that we're doing. We got a great team of evaluators, finance folks, and contract folks that turn all those wheels to make that stuff happen. Department of Air Force users can also submit focus areas for inclusion in the next open topic call. We have an email for that, or you can go to our focus area site at afworks.com and look at our focus areas that are available. Department of Air Force users should check out what's already in the portfolio. There may be a technology or something that's already there that you can take advantage of and leverage off of, its current status. Specific topic programs. Toolset to solicit defense-focused capabilities based on predefined requirements and customer needs. So again, this is like your traditional, most of you familiar working with the Air Force Cyber Sitter program, called that the Legacy program, but this is the specific topics. So how to be involved with it. industry can submit capabilities based on specific topic criteria. You can check out our DSIP and DSIP and read those solicitations. We talked about that a minute ago at the Defense SBIR Innovation Portal. The Department of Air Force programs submit a problem statement, and we discover, what those solutions are that you submit to us very specifically to work that particular problem and opportunity. Department of Air Force users should check out what's already in the portfolio. Again, just like above in the open topic, we encourage you to sort through the portfolio and see if there's something, a technology that's already existing that you could even take to a phase 3 if they have that opportunity. So we encourage that as well. STRATFI TACFI, the strategic funding increase and tactical funding increase programs, provides follow-on and supplemental phase 2 awards. Again, we use the STRATFI TACFI to help companies cross that, what we call that valley of death, to try to bootstrap them over and get that tech into the hands of the people that need it, and get that transition and commercialization to happen. And if you have questions, we have the website. Our STRATFI TACFI is on there as well at our afworks.com. We're going to cover that here in a minute. Next slide. So one quick thing before I get to the resources. Today we had a kickoff of what we call AFWORKS 3.0. We've been currently working in the AFWORKS 2.0 up until today. We have a little bit more emphasis put on what the Secretary Kendall had put in place called operational imperatives. It's a top-down and bottom-up process. It's going to be used to carry forward objectives and priorities throughout the Department of Air Force senior leadership group. Be advocating for warfighter and the end user identified capability needs. So there will be a lot more emphasis as we move forward into selection of awards and all, making sure that these types of technologies are targeting our operational imperatives. Classified topics. Air Force Ventures is working to reduce the barriers to entry for those classified topics, so that we can help streamline our process and make things happen on a better timeline and get those things into the hands of the people that need it without taking forever. Revitalize focus areas and matchmaking tools. Air Force Ventures has a new automated matchmaking tool in production, going to be released in the summer of 2023. Better ingest end and user customer capability gaps. Streamline matchmaking between small business and Department of Air Force customer organizations, and facilitating market research for increased phase 3 opportunities. So we look back and we try to decide how well have we been doing by the numbers. Once AFWORKS has been working in this ecosystem that we've been, we want to, what's happened, what do those numbers look like? So in FY21, the phase 3 contracts having increased 330% versus what we were doing in FY15 and 18. Baseline, for that is, we're talking about 293 million to 980 million annually. So we moved from 300 to, almost $1 billion annually. Air Force Ventures portfolio companies received 1.9 billion in post-SBIR award government contracts in FY21. Department of Air Force SBIR portfolio companies are growing 2.7 times faster than the pre-AFWORKS. Open topic has decreased average time to award by 62%. For phase 1's 171 days to 64 days, and 45% for phase 2's from 228 days to 125 days. So, the statistics tell us at least we're doing a better job than we were in the past, and we're always working to try to make that better if we can. Resources, as I mentioned before, we have the focus areas. You can support, or you can submit your ideas to our focus.areas at afworks.af.mil. Open topic company portfolios. There's a website for that as a resource. Our weekly seminar series that we have, and then finally our afworks.com site. We're working on that. We're trying to get better at it. Every day, I think there's new material that's added up there. We're trying to make that a little bit more streamlined and easier from the user standpoint coming in on your side. And that's all I have on my side. Dell? Back
We
to you.
actually had a question come in for you, Mike, and I think it's actually very fitting because you're talking directly about phase 3 stuff. But the question came in, so to qualify for a DoD phase 3, does the phase 1 have to actually be from DoD, or can someone qualify if they've done a non-DoD agency?
So that's a great question. So, and I'm going to be maybe ignorantly speaking, but I have read the policy directive a few times, and I am a little bit familiar with it. But so once you've competed in a phase 1, and let's say, for instance, you've done some type of a technology that was maybe for Department of Agriculture, and you've competed in a phase 1 for that one, and it happens to be a technology that could be crossed over into DoD, and maybe we need that because it's a great de-weeding capability for the Air Force runway or something like that. That phase 1, there's actually 2 ways it can happen from a phase 1. So it could be brought over as a transferred from the Department of Agriculture to the Department of Air Force. It goes through the approval process through DoD and others, but it will eventually end up at the Air Force, and we are able to take that technology. And one, you could either create a you can move that into the SBIR program that's existing there, or you can move that directly to a phase 3. So you can do that through the local contract shops that are available, or you can do that through maybe it's the GSA that you're working with. Let's say that there's the Army likes that same technology, and the some other DoD components want to know how to de-weed things very well from the Agriculture Department. That particular technology could be contracted and crafted through the GSA, who can do some type of an IDIQ type contract and facilitate other people and provide contract vehicles for those different departments to participate. Again, phase 3, there would be no SBIR funding over for that. Does that answer the question?
Yeah, I think it does. So just to kind of culminate it for people, or to give that 35,000 foot level, by policy, it's theoretical. The mechanics are there, but it can be hard to kind of match what you have in a phase 1 versus what they would need, because at that point you're doing a direct procurement. They already have, you already are lined up with exactly what they're looking to purchase, and there can be a big gap that people have to overcome.
Yeah, you see it more in like a phase 2. So we've been talking about a phase 1. But let's say, we're with NASA and we're working on a phase 2 with NASA, and it's their phase 2. And we're similarly interested in that technology for our satellite program as well. And we want to leverage off, they had the initial phase 2. We could transfer that topic from NASA over to the Air Force or Space Force, maybe in that case, and they could take that up as what we call that second phase 2, sequential phase 2. Sequential is a little bit of a misnomer. They can actually go in parallel, but that second phase 2, would be the transferred product over from NASA over to the Air Force of that. It would be a SBIR phase 2 for it.
Great. Thanks, Mike. And thank you for presenting to our crowd today. Now, we are going to kick it over to you for closing remarks, Garrett.
Thank you.